Dear students, today we'll discuss about some special transformers under which we have current transformer, we have voltage transformer, we have pulse transformer, audio frequency transformer, as well as grounding transformer. So starting with current transformer, the current transformer is a type of instrument transformer that is designed to produce an alternating current in its secondary winding, which is proportional to the current being measured in its primary. Current transformer reduces high voltage currents to a much lower value and provide a convenient way of safely monitoring the actual electrical current flowing in a AC transmission line using a standard ammeter. The principle of operation of a basic current transformer is slightly different from that of an ordinary voltage transformer. Now, unlike the voltage or power transformer looked at previously, the current transformer consists of only one or few turns as its primary winding. This primary winding can be of either a single flat turn, a coil of heavy duty wire wrapped around the core, or just a connector or bus bar placed through a central hole as. So due to this type of arrangement, the current transformer is often referred to as series transformer as the primary winding, which never has more than a very few turns. Is this series with the current carrying connector supplying a load. The secondary winding, however, may have a large number of coil turns wound on a laminated core of low loss magnetic material. This core has a large cross-sectional area so that the magnetic flux density created is low, using much smaller cross-sectional area where, depending upon how much the current must be stepped down as it tries to output a constant current independent of the connected load. The secondary winding will supply a current into either a short circuit in the form of an ammeter or into a resistive load until the voltage included in the secondary is big enough to saturate the core or case failure from excessive voltage breakdown. Unlike a voltage transformer, the primary current of a current transformer is not dependent of the secondary load current, but instead is controlled by an external load. The secondary current is usually rated at a standard 1 ampere or 5 ampere for large primary current ratings. Now we move on to potential transformer. In case of potential transformer, it is not an easy way to measure the high voltage and currents associated with power transmission and distribution systems. Hence, instrument transformers are often used to step down these values to a safer level to measure. This is because measuring meters or instruments and protective relays are low voltage devices, thereby cannot be connected directly to the high voltage circuit for the purpose of measurement and protection of the system. In addition to the reduction of voltage and current levels, these transformers isolate the measuring or protective current from the main circuit, which is operating at high voltage levels. Potential transformer is a voltage step-down transformer which reduces the voltage of a high voltage circuit to a lower level for a purpose of measurement. These are connected across or parallel to the line which is not monitored. The primary winding consists of a large number of turns which is connected across the high voltage side or the line in which measurements have to be taken or to be protected. The secondary winding has lesser number of turns which is connected to the voltmeter or potential coils of wattmeter and energy meters, relays and other controlled device. This can be single phase or three-phase potential transformers. Irrespective of the primary voltage rating, these are designed to have the secondary output voltage of 110 volt. since the voltmeter and potential coil of other meter have high impedance, a small current flows through the secondary of PT. Therefore, the potential transformer behaves as an ordinary two-winding transformer operating on no load. Due to this low load on the PT, the volt-ampere rating of potential transformers are low and in the range of 50 to 200 volt ampere. On the secondary side, one end is connected to the ground for safety reason in all cases of potential transformers. Now we move on to pulse transformer. A pulse transformer is a transformer that is optimized for transmitting rectangular electrical pulse, that is pulse with fast rise and fall times and a relatively constant amplitude. Small versions called signal types are